For the quadratic equation ax square plus bx plus c is equal to 0, the formula to find the roots of the equation is x is equal to minus b plus or minus root of b square minus 4ac whole divided by 2a. This session we are just going to derive this formula. An equation with its unknown having a highest power as 2 is what we call it as a quadratic equation. So the general form of a quadratic equation will be ax square plus bx plus c is equal to 0, where this a, b, c are constants. And importantly, that a value should not be 0. That is, a is a non-zero value. Because if a becomes 0, then this highest power will get vanished and this will no more be a quadratic equation. So this equation is what now we are going to solve and find the roots. Let's start with the equation. So first step, what I'm going to do is, we have ax square plus bx plus c is equal to 0. Here we have x square's coefficient as a. In order to free that x square's coefficient, what I'm going to do is, I'll just take that a as a common factor outside. So when we do that, we'll be having a times of x square plus, I have removed a from here, so I'll be having b by ax plus, again we are removing a from here, we'll have c by a, which will be equal to 0. And next we will just send this a to the right hand side, so that we'll get 0 by a, which will be nothing but 0. So we have x square plus b by a x plus c by a is equal to 0. And now once again what I am going to do is, I will just take this plus c by a to the other side, so that we will be getting x square plus b by a x, which will be equal to minus c by a. So we have this plus c by a this side, when it goes to the opposite side, we will be having it as minus c by a. And next what we are going to do is, here only we are going to use the completing the square methods technique. We have already seen in an elaborate way what about that completing the square method. So if you have missed that video, I have attached the link of that video also here. You can just see that video so that it would be more interesting and more easy for you to understand what we are going to do here. Okay, so what I am going to do here is, see here we have x's coefficient to be b by a. So it is b by a, we'll have to take the coefficient of x and we'll have to find the half of this b by a. So half of b by a is nothing but 1 by 2 into b by a, which will be simply b by 2a. And now I'm just going to square this term. So when I just square this, I'll be getting b by 2a the whole square, which will be getting the result as b square by 4a square. Now what I'm going to do is, I'm just simply going to add this b square by 4a square to the two sides of our equation. So we'll be having plus b square by 4a square, I'm adding it to the left hand side, and in order to compensate the equation, we'll have to do the same thing in the right hand side also. So here also I'm just adding b square by 4a square. So let us now continue, and before that we have this one, right? We have this left hand side. We'll just try to remodify what we have in the left hand side. Okay, so what I'm going to do is, let me just show it properly, observe it here. So I'll write it as x square plus, see the second term we have b by a into x. Let me write this term in a more modified way, like 2 times of x into b by 2a. So I'm just exactly rewriting this term, that is b by ax, in this way, so that when I just cancel this 2 with this 2, we'll be having this original step itself, what we have in the previous. And let's continue. Plus this b square by 4a square, once again I'm writing as b by 2a the whole square. So which will be nothing but, see the right hand side, I'm just going to take the LCM on the right hand side. So I'll be getting, here I have 4a square and here I have a. These two are my denominators. So our LCM will be 4a square. And now coming to the numerator, I have 4a square here. So the same term is available here. So the same numerator will be coming here. So b square minus, and now here the second numerator is c here. Here I have denominator as a. This a is becoming here as 4a square. So which means it is getting multiplied with 4a. So the same should be done with the numerator also. So I'll be having 4a into c, which will be nothing but minus 4ac on the right hand side. Okay, let's again continue. Now have a proper look, a close observation on the left hand side, if you observe it here, you can realize that we have our left hand side in the form a square plus 2ab plus b square. So this is actually nothing but the identity of a plus b the whole square. That is, in the place of a we have x, and in the place of b we have b by 2a. That's it. So we can very well rewrite the same term like this. That is x plus b by 2a the whole square. Hope we can understand this step. That is, I have a square plus 2ab plus b square. The same thing is what rewriting. I'm just rewriting as a plus b the whole square. So that once again, if you expand this using the identity, we'll be just getting back this previous statement. Okay. And next, let's continue. So this will be once again equal to, right hand side we have the same term, b square minus 4ac whole divided by 4a square. Let us just continue it on the right hand side. And now what I'm going to do is, our objective here is actually to find the value of x. So we need to keep x alone on the left hand side. So we'll have to try to chase all the other terms to the right hand side. So I have x plus b by 2a the whole square. So what we can do now here is, we can just take square roots on both sides. So once I do square roots on both sides, okay. Once I try to take square roots on both sides, what happens is, our left hand side will be free from square. That is, we'll be having x plus b by 2a, which will be equal to, coming to the right hand side, we have b square minus 4ac whole divided by 4a square. So this whole thing comes under root, but since we ourselves take square root on both the sides, we will be inserting a plus or minus. So we'll have plus or minus of root of this entire term, that is root of b square minus 4ac whole divided by 4a square. Now on continuing, we'll get x plus b by 2a, which will be equal to plus or minus root of, I'm just applying that plus or minus and I'm just applying the root to the numerator now. So we'll be having root of b square minus 4ac. I've taken the root for the numerator term. Now coming to the denominator, I have root of 4a square. So once I take root 4a square, I'll be having root 4 will be 2 and root a square will be simply a. So we'll be having 2a in the denominator. And now again, we need to finally find the value of x. So x will be equal to, let us just chase this plus b by 2a term to the right hand side, so that we'll be getting minus b by 2a plus or minus root of b square minus 4ac whole divided by 2a. And now if we see here, both the terms we have 2a as a common term, common denominator. So once again I can rewrite the same step like this, whole divided by, I can make it as a common 2a, and numerator will be left with minus b plus r minus root of b square minus 4ac whole divided by 2a. And this is how we get the quadratic formula for a quadratic equation ax square plus bx plus c is equal to 0. And here we are left with the roots of the quadratic equation, that is the value of x to be equal to minus b plus r minus root of b square minus 4ac whole divided by 2a. And here we actually have two values for x. Since we have this plus r minus, we'll have the two terms to be x is equal to either minus b plus root of b square minus 4ac by 2a, or the other one, which will be minus b minus root of b square minus 4ac by 2a. And this is how we derive the formula to find the roots of a quadratic equation. For more math concepts like this, kindly subscribe to my channel VAAGAI Math Coaching, and also share to your friends. Again, let's catch up in the next session soon. See you there. Thank you so much.